Let's take a look at confidence intervals for mean with unknown standard deviations. When our standard deviation comes from a sample, it's considered unknown standard deviation because we don't know everything there is to know about the entire population. That can be a little bit confusing because we can still calculate a value, so it is known to some extent, but the statistical terminology calls it unknown standard deviation because it's coming from a sample. So we don't know with 100% certainty. So let's take a look at an example of how we would calculate a confidence interval for a mean with unknown standard deviation. Let's suppose we have a sample of 7 calls that come into an IT help desk. They're tracked to measure performance. We're using a data from 7 samples, so a very small sample size, and we've determined that the average call time is 24 minutes with a standard deviation of 3 minutes. We can use this information then to calculate the 95% confidence interval for our mean or mu, assuming that each sample is from a normal population. So here, our confidence interval calculation changes slightly. We're going to calculate our confidence interval as equal to x bar, which is our mean, plus or minus our t value. So our t distribution is used here, the student's t-test, because our sample size is so small. General rule of thumb is that it's less than 30 samples. And in this case, since we don't know everything there is to know about the population, we know for sure we need to use the t distribution, particularly because our sample size is only 7. We're going to multiply it by our s, which is our sample standard deviation, rather than sigma, which is our population standard deviation. And then we're dividing it by the square root of n. Given the information that we have, we can go ahead and fill in some of our values. We know that our sample size is 7, our average, x bar, is 24, our sample standard deviation, which is s, was 3, and we're looking for a percent confidence interval. So this calculation will be slightly different because we're using the t distribution. So here we're going to enter a value as a decimal. In this case, we're solving for the 95% confidence interval, so we're going to use a value of 0.95. We're going to calculate the percent confidence that we're looking for, so that's our 1 minus 0.05 that we're going to use in our equation. Our degrees of freedom, since we're using a sample, is n minus 1. Our n value of 7 from cell B17 minus 1. Since it's a sample, we lose a piece of information, so we have to take into account our degrees of freedom. And then for our t distribution, here we're using the t dot inverse, inv dot 2t function to calculate our value. And here, to get our value for t, it's based off of 1 minus the confidence that we're looking for, so our value of 0.05, and then our degrees of freedom, which comes from cell B22. So our t value in this case is 2.4469. Now we have all of the information for our calculation. The first part of our calculation is going to be our x value, our x bar value, which is 24. And then we're going to calculate our t for alpha over 2, which comes from cell B23, which was our value of 2.4469. We're going to multiply that by our sample standard deviation, our value of s, which was 3, and we're going to divide by the square root of our sample size, which was 7 in cell B17. Once we have this, we can calculate our range then. So our lower confidence interval will be 24 minus 2.7745, and our upper confidence interval will be 24 plus 2.7745. So we can say with 95% confidence that our values will be will be between 21.2255 and 26.7745. As I mentioned before, our sample size is in our denominator. Our sample size is a key part of our calculations. So what I would like to do is show you how it has an impact on our calculation. So without changing the problem statement, let's just assume for a minute that our sample size is still small. We're still getting this from a sample, not a population. If I were to change my sample size, and in this instance, I have values of 21.2255 and 26.7745, let's, for example, assume that our sample size doubled, and I'm going to change the number then to 14. And I want you to pay attention to what that does with our confidence interval. It's made a pretty significant impact on reducing our confidence interval because our sample size and how it impacts our calculation. So as we're making business decisions using this data, we need to understand the importance of having a large enough sample size, which in some instances can be very costly, very expensive, depending on how you're collecting data and what your industry is. But understanding the impact of the sample size on your calculation is an important consideration when you're making business decisions.